It is the silent pulse of our modern world, powering the machines that drive us and the devices that connect us. But how is this energy captured? To understand the battery, we must look inside. It is a masterpiece of layered precision. Chemistry in motion. Ions traveling through a microscopic landscape to store and release power. Every layer is engineered for maximum efficiency from the molecular level up. The balance of these materials determines the very life of our technology. A thin barrier, preventing chaos while allowing energy to flow. Structured, precise, powerful. A grid of energy waiting to be unleashed. Clean, efficient, the foundation of a renewable future. The journey begins deep within the Earth's most remote landscapes. Extracting the raw elements that will eventually power our cities. Lithium, the core component. Light, yet incredibly energetic. Cobalt and nickel, essential for stability and high-capacity performance. And graphite, creating the architecture for the ions to reside. Raw materials are refined and transported to the heart of production. Automation ensures precision that no human hand could achieve. A global supply chain operating at an unprecedented scale. From raw earth to high-performance energy storage. An industry that spans continents, connecting resources to innovation. Millions of cells, ready to power the next generation of human progress. This is the future, engineered today. The heart of the energy revolution lies here, in the meticulous world of electrode manufacturing. It begins with the slurry, a precise blend of active materials, binders, and conductive agents. Every drop is measured, ensuring the foundation of the battery is flawless. Accuracy is measured in microns as high-speed coaters create a perfectly uniform surface. Controlled heat tunnels then evaporate the solvents, curing the electrodes to perfection. The balance of temperature and speed is critical for structural integrity. Massive rollers then compress the materials, maximizing energy density for the miles ahead. The result is a highly conductive, compact layer ready for the next stage. Internal inspections reveal the hidden perfection of the aligned layers. We move into cell assembly, where the components are brought together with robotic surgical precision. Every sheet is cut to exact specifications, leaving no room for error. The separator, the critical barrier, unrolls with microscopic accuracy. Layer by layer, the energy storage core is wound into its final form. In some designs, layers are stacked, optimizing space for high-performance applications. The cores are then encased in steel, protected for their lifetime of service. In this controlled environment, silence reflects the absolute absence of contaminants. The catalyst for energy flow is now introduced, a precise injection of electrolyte. Vacuum systems ensure a pure internal environment, removing every trace of air. Lasers seal the destiny of the cell, creating a permanent, airtight bond. Because even a molecule of oxygen could compromise the cell's stability. Every seal is verified in real time by a network of high-precision sensors. Now, the cell's enter formation, the first breath of life for the battery. Electricity begins to flow, activating the chemistry within. Computers track every millivolt, ensuring the cell meets the highest standards of performance. Thermal imaging ensures safety, verifying that heat is managed with perfection. To earn its place in the world, the battery must survive rigorous stress tests of vibration and heat. Individual cells are joined into modules, the building blocks of the modern electric world. These modules become packs, the silent power plants of the transport revolution. From city grids to remote solar farms, these batteries store the promise of a cleaner future. Ready to power the world, they are shipped across the globe. But the journey doesn't end here. The next generation of solid-state energy is already taking shape. A future powered by clean, reliable energy, driven by the innovation of today. The power to change the world, refined to the atom.